Hey, greetings and welcome. Going over part 2 of the homework on two-way tables and probability. And today we're talking about conditional relative frequency is kind of the primary thing we're looking at, as well as trying to figure out whether or not some of these events are independent if all I had was a two-way table. So here we go. Let's see. Here's modeling with mathematics. A survey finds that 110 people ate breakfast. And so I'm actually going to make a frequency table before I do a relative frequency table. I always find that it's helpful. And this is, by the way, the total number of people that ate breakfast. And even though my little table here didn't have a totals margin, I'm putting it in the margin anyway. And 30 people skipped breakfast, so we'll put them in the did not eat category. Then, of those who ate, 10 people felt tired. So from the 8 column, 10 were tired. And of those who skipped, 10 people felt tired. All right. And so, I've got enough to tally across and get the total there. Here, I could figure out the not tired people who ate by doing this, take away that. And the not tired people who did not eat by doing 30 minus 10. And getting 20. Add across, I get 120. This is 140, and this is 140 either way. All right. So let's see. Make a two-way table that shows the conditional. All right. So conditional. All right. So we're going to be doing kind of those given probabilities. Conditional relative frequencies based on the breakfast totals. And so this matters. This matters is depending on whether or not I'm working in rows or columns. Now, sometimes I do the table in between these, in which I compare to the total, all right, which would be the joint relative frequency. If I did 10 over 140, that would be a joint relative frequency. If I did 20 over 140, that would be a marginal relative frequency. But if I'm not using this, and I'm working based on the breakfast totals, I can actually jump right into the conditional. All right, where I'm only looking at a column at a time. All right, and so let's see. So this column would be out of 110. That's the total number of people who ate breakfast. And this column was the 30, the number of people who did not eat breakfast. And so those would be the respective denominators for those conditional probabilities. And then I would take the joint marginal or joint frequency, let's see, which is 10, 100, 10, and 30. And so if I divide these out, I get 0.091, so just about 9%, 0.909, about 91%, 0.333, and 0.667. And so the 0.091, 9.1%, another way I could say that, are the probability that someone was tired. All right, if I look at just this cell, is the probability that someone was tired given I already knew they ate. And right, so because the denominator, the possible outcomes was not the total, I was working with a conditional, right? Conditional probability, given probability, a conditional relative frequency. Whew, man, I'm practicing this vocab myself, friendos. And so, yeah. So that's how that works. So this would be the probability that someone was not tired, given I already knew they did not eat. Okay. So it appears as though, yeah, that's all set. They didn't need me to do any more analysis on this. Nope. Conditional relative frequencies. Good to go. All right, here's question 14. A researcher surveys a random sample of high school students in 7 states. The survey asks, this might be relative to some of you guys, whether or not the students plan to stay in their home states after graduation. The results are given as joint relative frequencies shown in the two-way table. All right. So, so these are the joint relative frequencies. It might be helpful for me to figure out the totals, and I'm going to do that. I like having those marginal relative frequencies. So this one would be 0.444. This one would be let's see. Ooh, let's do some column math. So this is also, 4, carry the, 244, hopefully I'm getting this right. This would be 2. Oh dear, now I'm messing it up, Waddy. All right, so this is 2, carry the 1, and then this is 11, carry the 1, and then this is 3. All right, hopefully I'm doing this right. I'm not going to try to add 3 across, especially horizontally. Let's see. Here we go. 0.044 plus 0.051 plus 0.056. I get 0.151. And 0.4 plus 0.193 plus 0.256. Here I get 0.849. And notice if I add these, I get 100% in this cell. And if I add these, let me just verify, because it's not a bad idea. Boom, and it adds to 1 across. All right, whew. So now this is the joint relative frequencies. These are the marginal relative frequencies. And now we're going to figure out conditional, right? Let's see. What is the probability that a randomly selected student who lives in Nebraska, so lives in Nebraska is my given. And so I'm working with this here. Who lives in Nebraska, plans to stay in his or her home state after graduation. So plans on staying is this number. Lots of 4s here. And if I divide that out, I happen to get about 10%. 10% of them. Am I right? Am I right? Okay, what is the probability that a randomly selected student who does not plan to stay, so this is relative to the row, so I'd be looking at this entire row across, so these are the not stayers, so the denominator would be 0.849. So of those who do not plan to stay, what's the question? Lives in North Carolina, so right there, 0.193, and that is equal to 0.227. And so 22.7% of students who don't plan to stay in their home state were from North Carolina. Okay? All right. Yeah, getting the language of these were different from one another, whereas this was of those who lived in Nebraska who planned on staying was 10%. Okay? And so this would actually allow you to even kind of analyze, like, you know, do students not enjoy their home state as much as students who live in other states, or at least, you know, their future plans. Maybe they do enjoy it, but maybe, you know, career paths aren't available, or college or whatever isn't available for them there. All right, now these are the trickier questions, and this is going to be a little bit interesting. Determine whether planning to stay in their home state and living in Nebraska are independent events. And so if they're independent events, there's actually 2 ways to look at this. So staying in home state and living in Nebraska are the 2 things I'm considering. And there are 2 ways to set this up, and I've actually pre-calculated a bunch of this math here for us, because I wanted to point out that there's 2 ways of doing this problem, and I didn't do this full explanation in the lesson video. So here we go. I could analyze this 2 ways. Now it doesn't matter which way I do it, because I could have done focused on stay at home versus living in Nebraska. Doesn't matter which way. Okay. So this is one analysis where I'm doing the Nebraska view. So what's the probability that someone lives in Nebraska? One of those students lived in Nebraska? Well, I added the entire column of those who lived in Nebraska. And then I did what's the probability that someone is from Nebraska, given I already knew they planned on staying home. And so the numerator was still the same, the 0.0, or the numerator was still the, those who said yes and Nebraska. But I'm adding up this entire row of all those who were saying they planned on staying home, which actually is only, looks like 15%. And so by adding all that up, I end up getting that. And now because this value and this value are different, all right, different, therefore these events are dependent on one another. So there seems to be some sort of influence that living in Nebraska has with wanting to stay home after you're done high school. All right, so that's what that's indicating. And what I wanted to point out that it wasn't clear in my lesson video is that I could have analyzed this the other way. I could have focused on the stay home side of things. And so if I find the probability that someone's staying home, which is the 0.0151, which is what I have there, and then calculate the probability is someone going to stay home given they're from Nebraska, and so that's the 0.044, and then I divide all people from Nebraska, which is the trip 4 right there, and I get this value, and because they are different, therefore there is a dependence, let's see, diff, therefore there is a dependence going on. All right, and so clearly students will have a preference based on what state they're from. It's not just this general angst that teenagers have, that all of them happen to have the same preferences to whether they're staying home or leaving their state. That which state you live in happens to have some influence there. I wonder where Vermont would land on this scale. All right, here, last question. All right, so that one takes a little bit more explanation. All right, a teacher is assessing 3 groups of students in order to offer one group a prize. Over a period of time, the teacher records whether the groups meet or exceed expectations on their assigned tasks. Okay, and here are the results. Which group should be awarded the prize? So I'm going to do a frequency table here, because tally marks, yeah, I guess you could write the number right next to it, and that kind of would work, although the totals will be helpful to us as well. All right, so this is 5, 10, 12. This is 5 plus 3 is 8. 5 plus 4 is 9. Here is 4. We've got 5, and we've got 6. And then let's total across. 16, 13, 15. And what do I get? 5, 8 plus 6 is 14. Is that 44? I think so. And then let's add down 29. And 4 and 6 is 10, 15. And 5 and 9, 14 plus, yep, 44. Good. And what do they want us to do? Which group should be awarded the prize? Now, so in order to figure that out, I'm going to need to figure out some conditional relative frequencies. So I think the way you could figure it out is base it off of the look at how often they exceed expectations per group. So we'll figure out, oh, actually I could do that this way as well. I've got to figure out the other frequencies. I could I jump right into conditional? Conditional by row? Yeah, I could do that. I think I can. There's a few different ways you could do this. I could have found the joint relative and marginal relative and then done the conditional. But based on the previous example, I could jump right into conditional. So I'm going to do this given group. Okay, and so I'm looking at how often do they exceed given what group they're from. And so this would have been out of 16. This would have been out of 13. And these are conditional because I'm using these values rather than the total group, right? So out of 13, out of 15. And then the numerators would have been exceed expectations is 12, 8, and 9. And then let's figure out what those are. So 12 sixteenths happens to be 0.75. So group 1 went above and beyond 75% of the time. Group 2, 8 thirteenths. Did I get this right? 8 thirteenths? Did I do that right? 8 13, 8 13. And then 9 fifteenths. And I get, let's see, 0 point exceed and from group 3, given their group, yep. And I get 0.60 here as well. Wait a minute, that's not right. 8 thirteenths. Here I'm getting 0.615. So we'll call that 0.62. All right, and so I don't actually care as much about the not meeting expectations. Theoretically, this would just be 25%. Well, I'll write down these parts anyway, but that would have been 4, that would have been 5, that would have been 6. And so based on the group that most often exceeded expectations, group 1 deserves the prize. Yeah, and this was a relatively fair number of times that it was measured. They did happen to be measured the most number of times, but it wasn't terribly far off. They did happen to have the most total number of exceeded expectations, but that doesn't necessarily guarantee things, because notice this 8 was smaller than the 9, but by percentage of the time, group 2 was actually exceeding more frequently than group 3. So yeah, so you can't just necessarily base it off of you're looking at these numbers. Finding these individual probabilities does have value. All right, well, thank you so much for watching, internet friends. Hope you all have a great day. Adios.